Okay, we got a variety of ways of doing number one. Just going back to math and they gave you a formula for it. So for the axis symmetry, the AOS, that was x equals minus b over twice a, with the understanding that you had a quadratic of this form over here. Let's write that down. So the axis symmetry for this particular problem is going to be x equals, well, what do you get there? Well, the opposite of the b would be minus 12, and twice a would be 6. So the axis symmetry would be minus 2. Let's write that down. The AOS is x equals minus 2. The vertex is on the axis symmetry. So let's write that down. Vertex. This is the method you were told in Math 100. That's minus 2. And then you got to plug it in. Where do you plug it in? You plug it into the function right over here. Let's write that down. So y is equal to, well, when you square minus 2, you get 4. So 3 times 4 is 12. Then 2 times minus 2 is minus 24 and minus 7. So what do you get there? Well, 12 minus 24 is minus 12, and minus 12 minus 7 is minus 19. So I got this. Put a box on it. And that's certainly one way to do it. I'm going to go to another way of doing it, and it goes back really to standardized translation. So let me erase all this business over here. And what I'm going to do is put this in, like a standard form, which makes it easy to read this information from the standard form. Let's write this over here. F of x, that's what y is. I factor the 3 out. You get 3 times x squared plus 4x. That's minus 7. I'm going to complete the square. Half of 4 is 2. When you square it, you get plus 4. And I'm really adding 4, which means I got to subtract. I'm sorry, I'm adding 4, but it's 3 times 4. I'm actually adding 12, so I need to subtract 12. So we give here f of x is equal to 3, x plus 2 squared minus 19. And you can pretty much read the vertex from this thing because it's a standard translation. So the vertex from this thing over here, the standard vertex of 0, 0. So what do? We move the 2 units to the right, to the left, and 19 units down. Axis symmetry goes through the vertex, so x is equal to minus 2. We're getting the same information. If you were to graph this out, though, I'd point out that I'm not really looking for a great picture of it, but a rough picture. So minus 2 minus 19. I'm going to say it's over here somewhere. Let's see, the y-intercept minus 7. So, something like this over here. And again, this is a rough picture. And that's it. Thank you.